Today we'll be learning a little bit about bloodstain patterns, but mostly we'll be learning about how we can calculate exactly where the blood originated from that has caused these patterns. So let's get to it. Bloodstain patterns deposited on floors, walls, bedding, and other relevant objects can provide valuable insights into events that occurred during the commission of a violent crime. The crime scene investigator must remember that the location, distribution, and appearance of bloodstains and spatters may be useful for interpreting and reconstructing the events that produced the bleeding. Here's a list of the things that bloodstain pattern interpretation can uncover for us. The direction the blood originated from, the angle that it struck the surface, the location or position of the victim, the movement of a bleeding individual, approximate number of blows, the approximate location of the individual delivering the blows. So there's a lot of information that we can get from bloodstain patterns. Some characteristics of blood: it's a fluid mixture. It's going to behave in a very predictable manner because it is fluid. Viscosity refers to the thickness of blood and its resistance to flow. Gravity and air resistance are inversely proportional to the size of the droplet. The larger the droplet, the less effect gravity and air resistance have on them. The smaller the droplet, the greater the effect. So basically, a smaller droplet will not travel as far as a larger droplet because of gravity and air resistance, and will lose velocity as it falls to the ground. Another characteristic is surface tension. That's the ability of blood to stay as one mass. Surface tension enables blood droplets to maintain a sphere shape. Free-falling blood will fall as a small sphere, and you can see that in this picture here. And then the drop is going to form a circle as it hits the surface. And the size of that circle that it makes depends on the speed of the blood drop. The shape of a stain is a function of the surface texture. If it's a smooth surface, there's less distortion. If it's a hard surface, there's less distortion. If it's textured, there's more distortion. If it's soft, there's more distortion. The harder and less porous the surface, the less spatter results from it. The height that a drop comes from also will affect. Here's pictures of blood falling from different heights. The heights are over here in meters. Here we have the different surfaces they're falling to. So you can see the difference in what they look like based on what they fall onto. The area of origin of an impact bloodstain pattern is the area in a three-dimensional space from which the blood was projected. It's where the blood came from originally. This will show the position of the victim or suspect in space when the stain-producing event took place. So how do we do this? Step 1, you need to find some good blood spatter and determine its direction of travel. And investigators will look for spatter with directionality. In the actual blood stain analysis, a forensic investigator will determine the trajectory of the blood. Directionality can be determined by analyzing the tail of the blood stain. By measuring the shape of the blood stain on a surface, the direction of movement can be determined. As well, the speed at which the blood contacted the surface can be approximated. Blood always travels in the direction of the applied force. So the direction of travel of blood striking an object may be discerned because the pointed end of the blood stain always faces its direction of travel. If we're looking on these, here's the pointed end. So that means the blood came from here and is traveling this direction. Like it says here, the absence of a tail indicates that the blood is dropped from a 90-degree angle, and that's a passive drop or a gravitational drop. Again, the pointed end always faces in the direction of travel. Here's that 90-degree stain. Here's one that had directionality. Some more examples. Our next step is to string the blood. The location of the source of blood can be determined if there are at least 2 drops of blood spatter. In order to determine the point of origin, investigators must use a method called stringing to find the area of convergence, or AOC. The string method is commonly used at a crime scene to approximate the position of the area of origin using found angles of impact of individual stains in the pattern, and we'll learn how to do this. Once the AOC is determined, a quick trigonometry calculation can yield the point of origin. In your assignment in class, you'll be doing this by drawing lines rather than actual stringing. You'll determine the directionality of the blood droplets, and the lines are going to be drawn away from the direction of travel. The pointed end is here, meaning that the blood is traveling this way. We're going to draw the lines this way. You're going to draw a straight line through the middle of the oval of the blood droplet, running along the length. Step 3, you're going to determine the angle of impact for several of the drops. And that is a trigonometry calculation using the law of tangents. To determine angle of impact, we're going to measure the length and the width of the drop in millimeters. And you're not going to include any extensions from the drop. You're going to use just kind of the main oval point of it. Divide the width by the length. You should have a number that is less than 1, and then you'll take the inverse sign or the arc sign of that ratio, and that will give you the angle. So let's calculate the angle of impact for this blood spatter. Our width is 1.5 centimeters. Our length is 3. We'll take 1.5 divided by 3, take the arc sign, and that will give us a 30-degree angle. That means it hit the surface at an angle of 30 degrees. Here's another one. Our length is 6 millimeters, our width is 6 millimeters. We divide that, we're going to get 1. You take the arc sign of that gives us 90 degrees. Then investigators are going to use a protractor using those angles that we came up with and pull the strings out at that angle. You'll place the protractor's origin, that's the middle of it, on the blood stain where it first strikes the surface, set the string at the calculated angle of impact for that blood stain, and the area where all the strings intersect above the center of the area of convergence is the area or point of origin. And this is what that can look like in real life.